Okay, so let's get into creating numpy objects. Alright, so to work with the numpy library, we're just going to type in an import statement. So import, say numpy, as, we're going to use alias, and if you don't know what an alias is, just refer to our tutorial on that. So here we go. So now that we have access to the numpy library. Alright, so to create an object from this library called nd array object, we define it in the following way. So a1, let's call this variable a1 mp.array, oops, there's a space there, dot array, there we go, autocomplete feature. So now let's call this a list of 2, 1, 3, 4. So there we go. So we're just going to print that out. Pretty simple. And there's our result. Alright, so aside from this besides this passed list, it's also possible to pass any parameter that is a sequence, for example, like a tuple. So we can actually demonstrate creating a two-dimensional array in the following way. So 2 mp dot array again, and then we're just gonna use square brackets. So this time we're gonna use 2. So you open first pair, open the second pair. Then we're gonna we're gonna define our elements. So we're gonna have a couple of them. 1, 2, 1, 2, 1, 2, and then space 1, 2, 3. Oops, I forgot to print that. Alright, so here's our two-dimensional array. Alright, so we can also similarly create a three-dimensional array, which is done in the following way. So let's say a3 equals mp.array. So now we're going to open 3 pairs. So if you notice a pattern here, the more brackets, square brackets we have, the more dimensions on the array we have. So here's 3 pairs of square brackets. Now we have a three-dimensional array. So we're going to name, just keep track of your square brackets. There we go. So we're going to open more, yes, open more, another pair, 2, 2, 2. 2, 2, 2. Then you open another pair, another 2. Oops, forgot the commas. Yeah, so be sure to space things out a little so it looks pretty clean and organized, and you don't get confused with a lot of these square brackets. Alright, so 3, 3, 3, and then we have 3, 3, 3. Alright, and then we're going to print this three-dimensional array. And there's our three-dimensional array. Alright, so if you recall, we had a method, is the range method from, if you recall the range method from loops. If you don't, just refer to our tutorial on loops. Anyway, so if you recall that, we have a similar function method to that in this library called arange. So let's demonstrate how that looks. So a4 equals mp dot arange of some sort of defined parameters. So we're going to have 10, we're going to have 3 parameters, 10, 50, and 10. So this is sort of an equivalent method to the previous range method in loops. So let me explain the parameters a little. Here we go. So the first parameter, this 10, is the starting value. The second is this 50 is the ending value. And the third is by how much we are increasing the numbers. So let's display this. As you can see, we got 10, 20, 30, 40. So the final element is basically this final number minus this one. I guess generally speaking. So that's that. So let's say we only want to pass one parameter. So let's do that. So we're just going to say, let's make a new one. A5 np.arange is going to just have 15. And then we're going to print A5. So what this did, it shows us that by default the starting value is 0 and the increasing step is by 1. So that's only when we have one parameter. So let's say we have two parameters now. A6 equals np arange, and then once again we're going to have two, this time not once again, we're going to have two parameters now. So what this, wait, I forgot to print it. Oops, my bad. Zoom out a little. There we go. Alright, so what this did, it just takes the starting range and the ending range and it gets that number increased by 1. So we don't just have to use integers. And aside from integers, we can use floating point numbers. So let's say we have A7 equals np.arange, and we're going to have starting point of 0.3 to 2 in increments of 0.2. So when we want to print that, you can see it gets up to that point as much as it can, as close as it can, but not quite. So from this we can gather that it's not recommended to use floating point numbers like this because of the imprecision of floating point numbers. But instead we have this following method called linspace. Looks like that. What this does is the following. Let's do this. It's a method that takes a number of elements as a third parameter instead of a step increase. So we have a new one called A8. If this is a new method now, linspace. I'd use nnp, my bad. And then linspace. And then we're going to have a starting point 3 and then the stopping point 8 in steps of 9. So, oops, I did a 9 there too. My bad. So instead of using a defined value for the increment, we have a number of steps instead. So everything will be figured out automatically. So as you can see, you get 9 steps up to 8, 9 steps from 3 to 8, and it does the calculations by itself. So moving on, we also have functions that allow us to create multidimensional arrays in which we know the dimensions beforehand. These arrays are filled with certain values because sometimes the content is sometimes important. Sometimes important. First, such function, the first one we're going to talk about, creates an n-dimensional array of ones. This method, is just typed out as ones. So let's say A9, going up the, actually let's start over. Let's call it O1, say NP, still using the NP library alias, ones, and the shape of the matrix or the n-dimensional, multidimensional array is like this. So 2, 2, 2, 2. So then we're going to display not 0, 1, rather O1. Oops, what did I do? Oops, forgot the parentheses, double parentheses. Don't forget those parentheses. There we go. So we got a 3-dimensional array in this following shape. So if we decrease this, we get a two-dimensional array with all ones. Similarly, we have a matrix. We can have a matrix where just all zeros are there. And this method is called simply zeros. And it does the same thing as before. Just this time, we have zeros. There you go. And then there's a 3-dimensional array. Alright, so that's that. The next function we have is similar, but it creates ones with on the diagonal. So we're going to call this one now. Actually, I should say that for after this before explaining. So we have another function called empty, which is similar as before, but the content of the array is not defined and can contain any value. So you're just making an array, just a multi-dimensional array. So in the parentheses we have the shape of the array, and then we're going to build it. So it's called E1, and just a weird numbers that are not defined by us. So we're gonna have another one now, another function called mp.I. What this is going to do is going to make a diagonal of ones in an array. So we have I, actually just only one parameter, 5, which is basically the matrix. Creates a matrix with the rows and columns of this size. Actually, we don't need double parentheses there. So we're going to display E2. Let's do that. Here we go. And similarly, if I change this to 3, that's that. Alright, so moving on, our last example for this tutorial is a function that creates a matrix filled with random numbers. So it's called, say, R1 now, a variable called R1, and p.random, random module, and we also have random. And we have the dimensions of the matrix 5 by 5. And then we're going to print this, R1. And there we go. So it displayed random numbers from the range of 0 to 1. And that's pretty much it for this tutorial.